What's up, gamers? Welcome to part 3 of the Armor vs. Health Exploration video series. So today, we're going to dive even farther into effective health. I really do like this measurement. I think it's the simpler of the two between this and damage percent reduction. So I really want to look into this and clarify some things. Because in my last video, I kind of randomly threw out in there, if you heard, that if effective health scales better with flat HP than armor, and I wanted to explain why today. And we're also going to learn what I like to call the rule of HP versus armor. Or this, obviously, as I said in my previous videos, can be magic resist, but I'm using armor for the sake of the video and assuming all damage sources are physical damage. So, at the top here, we again have our effective HP formula, but today we're going to look at it a little differently. You see our HP here, our base HP, nominal HP. We're actually going to multiply this, distribute it across the brackets today. And so this equation becomes HP plus armor times HP all over 100. So this is a little more easier when we get into some mathematics behind why HP is better scaling than armor. So I quickly first just want to give you this rule of HP versus armor because I think it's really important. I just want everyone to get this in their head. I'm going to write this in all caps. Oh no, not all caps. I'm just going to write it. By HP before armor. As we're going to explore in this video, HP is pretty much always better to buy before armor as a tankiness stat, because in order for armor, or magic resist in that case, to be effective, it needs HP, because armor is essentially a damage over time defensive stat. You need to take as much damage as possible for it to be as effective as possible. It grows in efficiency in that way. And so we really need to buy HP to have that stat before we can buy armor and it be effective. So that being said, let us look at some graphs real quick. Now, this red graph here in the top left, this equation is the effective HP formula, and I have variabilized nominal HP, your health. So I've assumed 50 armor here in the top, and I've variabilized your HP. So this is showing you on the x-axis your nominal health, and the y-axis is your effective HP, assuming you have 50 armor. Alright, things to note is that you go through 0, 0, because with 0 HP you have 0 effective health. So, and this is also a linear graph. We went through this in the last video. It's not too difficult to understand if you've seen that. And now we have this blue graph here. Now in this one I've done the opposite. I've variabilized armor here, but I've assumed 1,000 base HP, which is a pretty reasonable amount early game. And so yeah, so you might be wondering, why isn't this blue graph showing up? Well, that's just it. It is, but it's just so much higher that it's actually not even close. And there's two reasons for this. One, the slope of this blue line with health is much, much larger than that of the red line. And two, its y-intercept, or the point at which x is 0, the y value is much higher than that of the red line, because this one goes through 0, 0 down here, but this one goes through 0, 1,000 up here. Now, so why is that? Well, if we go back to our equation we made here, this, I'm just going to write this out here to clarify. Now this is actually a subset of a linear equation here. So this, if you don't know, is the equation of a line on a graph. And what we can do is we can draw some correlations. So y is effective HP. We've already seen that on the graphs. The y-axis is the effective HP value. mx, which is m is your slope and x is your variable. Since we variabilized both HP and armor in different scenarios, I'm just going to keep mx as its like own entity because it's kind of hard to see. But if we look in here, this right here is going to be your mx for the most part. This isn't exactly 100% accurate because this actually can variabilize two parts at once. So it's kind of a little different, but for the sake of the video, we're just gonna do this simply. And B is your HP value here. So B, this is your y-intercept. So you can see if you variabilize HP, your y-intercept is going to be the x value. Or no, your y-intercept is going to be 0 because you're not actually you don't actually have an HP value to give it, basically. So when your x is 0, your y is going to be 0. But in the case of where you don't variabilize HP and you actually give it a value, your y-intercept will be that base HP. So when we made our base HP 1000 here, we actually made our y-intercept 1000. So that's reason one why this blue graph is so much more like better in terms of effective HP, because your y-intercept is so much higher because you actually have a base HP. This graph is technically assuming you have 0 health at the beginning of the graph, which is not the best. Here's part 2. mx, this is essentially your slope. We're just going to pretend this is the slope. It's not technically, only m is the slope, but it's easier just to assume that this is basically what is affecting our slope in this case. So this is armor times HP. Now, here's why this blue graph is actually so much more effective than the red graph. The slope of this blue graph is much, much higher. Why? Because it's much steeper. It's rising at a much greater rate. This thing is leveling off, but this thing is going much higher. The reason why the blue one is going so much higher is because we have not variabilized HP. The fact of the matter is 50 armor versus 1000 HP, though those are two pretty normalized league stats, in terms of this formula, it really is doing the same thing because armor and HP are multiplying each other. So if we put the flat HP value in here, the 1000, that's going to be way bigger than the 50, and it's going to make our slope much bigger as well, right? And so that means that this graph is going to increase at a larger rate than basically any graph that has variabilized the HP and used the armor, because any armor value you plug into this part is going to be smaller than pretty much any HP value you plug into this part. Alright, and so another thing to realize here is that when you change your HP or armor, when you change that variable within the formula, right? Here's another food for thought, one might say. If you are to change your HP value in this formula, so if you change HP, what happens here? Well, you're increasing your B or your y-intercept, because this is your y-intercept, and you're also increasing your slope. You're increasing your mx. Well, the same is not true for armor. Because as you can see, armor is only in the mx part of the equation, so you're only gaining mx if you change armor. So this is another reason why HP is so much more effective, because you're both increasing your slope and the starting point of your graph on the y-intercept. making it like just that much more effective as well. Another thing to realize, and this is just something obvious for League, changes in health are pretty much always greater than changes in armor. You know, if someone says, you know, I bought 15 armor, that's kind of a big deal because that's like a 300 gold item. But if someone says, I bought 15 HP, they're like, what? Like that's not even like a quantifiable buy you can make because it's just such a small amount of HP. So when you change your HP, you're generally changing more than you're changing armor. So change HPs are greater than change armor, which means that they're generally, the HP ones are generally going to be more effective because of that as well. And so, that being said, how can we translate this into our rule of HP versus armor? Well, as you can see, HP in pretty much in a straight-on case, and as you can also see from the graphs here, with the blue line being your HP and your red line being your armor graph, these are pretty much showing how HP is more effective than armor. And so obviously, when the two stats are starting at the beginning of the game at relatively low values, HP is going to be more effective at that point because there's just really no reason that armor would be more effective because HP is just going to increase your base effective health and increase your slope of your effective health so much more than armor will that there's really no point. Now, that being said, there will be a point at which armor will become more useful than HP because once you buy enough HP, it's going to have that diminishing returns effect where the next HP buy is not going to be as worth as the last HP buy because you already have stacked so much health. And then there will be a point at which armor will be as effective or more effective than HP in that scenario. And so because of that, I will show you in the finale of this series, the last video here, an actual formula or little trick in the mind using mathematics you can use to actually find that point. And I'll also show you different benchmarks you can think of in your mind so you can realize at what points armor or technically also magic resist could be the better buy than health in a given scenario. So I hope you learned something today when thinking about HP versus armor in terms of effective health, and I'll see you in the finale of this series.